Question number 2. A boy of mass 40 kg climbs up the stairs and reaches the roof at a height 8 meters in 5 seconds. Calculate force, work and power. G's value is given. So first of all, the force. Force is nothing but the weight. And weight is m into g. Values are given. We get the answer as 400 Newton. Work is F into S. Values are given. We get the answer in joule. Power is work upon time. We calculate and we get the answer in watt. Now the fourth sum. The weight is given as 200 kgf. Height is given and time is also given. You have to find the work and power. Well, if the weight is given, we can find the mass. And then we can use the formula work is equal to mgh. All the values are given, so we get the answer as 5000 joule. Power is work upon time. Substitute the values and get the answer as 1000 watt. Another way to do this is we can say force is equal to 200 into 10, 2000 Newton. You see, to convert kgf into Newton, we multiply with the value of g, which is given as 10. Now the sixth sum. The heater's power is given and time is given as 10 hours. We have to calculate the energy, both in kilowatt hour and joule. This is a very challenging sum, so pay attention. Yes, beautiful handwriting. Energy is power into time. Power is given, time is given, multiply and get the answer in kilowatt hour. The next, Roman number 2, they've asked us to convert this into joule. We know that to convert kilowatt hour to joule, just multiply by 3.6 into 10 raised to 6. Calculate that quickly like I did in 1 second out here and get the answer in joule. You may get the answer as 108 into 10 raised to 6 joule, which is also fine. Now the eighth sum. Mark it as IMP. Mass is given, depth is given, that is distance, height, time is given, work done, power and power rating. Now power rating means power input. Remember that. Now the solution. First of all, work done is mgh, values are given, get the answer in joule. Power is work upon time, get the answer in watt. Now efficiency. In this question, efficiency was given. The formula for efficiency is power output upon power input into 100%, because efficiency value is given in percent. Hence, we have to use 100% in the formula. In the next chapter, we will see another formula for efficiency, which is work output upon work input, which is the same thing because time and time get cancelled as time is same. Remember, output is always in numerator because output is always less than input. There is always degradation of energy. Energy is lost, power is lost. Output can never be more than input. Efficiency can never be more than 100%, not even 100%, because no machine is perfectly efficient. So we just substitute the values. Percent gets cancelled, cross multiply. We get the value of power input as 1 lakh watt, which is nothing but the power rating required. Now the 10th sum. Power is given, force is given, speed is required, or velocity. So the formula is power is equal to F into V. V will be 40,000 upon 20,000, that's 2 meters per second. No, I won't ask such easy sums in the test. Now the 12th sum. The weight is given, that is the force. This is not the mass, this is the weight. He climbs 30 steps and each step is 20 centimeters high. So the total height traveled or displacement is 30 multiplied by 20 centimeters. Time is given, work and power are asked. Now, height, first of all, let's calculate the height. 30 steps and each step is of 25 centimeters, so total height is 750 centimeters. Convert that into SI unit of meters. Now work is equal to F into S, so we get the answer as 2100 joule. Power is equal to work upon time. Convert 1 minute into 60 seconds, SI unit, to get the answer as 35 watt. Now the 14th sum. A boy of weight 40 kgf climbs up the 15 steps, each 15 centimeters high in 10 seconds, and a girl of weight 20 kgf does the same in 5 seconds. Compare the work and compare the power. Whenever they say compare, they want ratio. So this is how we'll solve. The ratio of the work done by boy to the work done by the girl is mgh upon mgh. G and G got cancelled, although the value is given in the question as 10. So we could have found the works separately and then taken the ratio, but I find this simpler. Masses are given. The weight is given in kgf, so we can take the mass from it in kg. Height is not given directly. For that, we'll have to multiply the number of steps with the height of each step. Now, we need not convert it into meters because the unit in numerator and denominator is same. So anyway, it's going to get cancelled. If you want to convert, you can. So the final answer should be written as a ratio and not as a fraction, 2:1. Please write the final statement in English. That is, the ratio of the work done by the boy and girl is this. Statements carry marks. Now, they want the ratio of power. Power of boy upon power of girl, overwriting. Very bad. So work upon time, which comes out to be this, the reciprocal of time here. The ratio of the work we have just calculated, we'll use that, and the values of time have been given. Even if the time would have been in minutes, I would not have converted it. It's not compulsory because it's a ratio. And we get 1:1, which clearly proves that girls are as powerful as boys. Although here I find it strange that the boy did more work than the girl. Usually it's the opposite. Now the 16th sum is IMP. A boy takes 3 minutes to lift 20 liters of water bucket from a 20-meter deep well, while the father does it in 2 minutes. Time is different, but the weight of the water seems to be same because volume is same, 20 liters each, and the height is also same, 20 meters. Compare the work done and the power developed. That is part A and part B, how much work each does. I'm going to start with part B first. Let's find the work done by each of them. Now in part B, we see, first let's calculate the weight of water. Weight is V rho G, volume into density into acceleration due to gravity. The volume was given in liters. We have to convert it into meter cube. So 20 into 10 raised to minus 3 to convert it to meter cube. Density is given and G's value is given. So the total weight, that is the force, is 196 Newton. Now we can calculate the work, F into S, 3920 joule. Write the final statement. Therefore, the work done by each is the same, 3920 joule. Now the ratios. The ratio of the work done by each of them is 1:1. They've done the same work because they've lifted the same weight of water by the same distance. But the powers are different. The ratio of the power is calculated like in the previous sum. Ratio of work we have found as 1:1, and the reciprocal ratio of time is 2/3. The time is given in minutes. If you want to convert it into seconds, it's fine. If you don't, it's fine because it's a ratio. So the final answer is 2:3.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.